Let's solve a medium JavaScript interview exercise using LeetCode. If you didn't know, LeetCode is one of the best possible resources for learning interviewing in general. And the reason why I recommend easy to medium LeetCode exercises for beginner and intermediate software developers, so not necessarily for seniors or staff engineers, but rather for like when you start in the industry in your first few years, is that most interviewers ask these types of questions, and up to medium is approximately the level that you can expect in interview exercises. Let them be automated or let them be manual. And for this reason, we're going to solve a simple interview exercise where you don't need to know many data structures. You just need to handle array of arrays, which is nothing else but a matrix. So in this situation, the task is the following. Given a positive integer n, generate an n times n matrix filled with elements from 1 to n squared in spiral order. Why n squared? Well, it's because if you have like a 3 times 3 matrix, then 3 squared is 9, and you have 9 elements in total. So 3 rows of 3 units in total. So that's why n squared. So in this case, you can imagine what is going to happen. It's always recommended to write a battle plan of how you're going to solve this problem. So create a matrix, obviously. So then iterate from 1 to n squared. So for example, for let I equal, or let num, or as a number, equals 1, num is less than or equal to n squared, and plus plus num. So you iterate, and then inside the iteration, you fill the matrix. So you put the correct number in its correct place and then return the matrix. So that's how the battle plan is going to work. And let's see how this iteration is going to work. So if you have a 1 times 1 table, then it's easy. You fill the one and only element. If you have a 2 times 2 matrix, then you go like horizontally, and then you fill out this value, and then you go left and fill out this value. Easy. If you have the 3 times 3 matrix, then you have another situation. So now I'm going to use rows like this. Okay. And these rows are going to be placed inside another matrix, another array. And I'll place them in commas. Okay. So that we know how this whole thing works. 1, 2, 3. And then we'll have a 4. Then we'll have a 5. Here we have the 6, the 7, 8, and 9. That's the spiral. Now, the good question is, like, is this approach good? Or is another approach good? That can we calculate that, for example, if you have these coordinates, that you have coordinate 1, 0. So matrix of 1, 0, for example, is going to be 8. Why? Because we start with 0 in indexing, and you select the first row. I mean, second row in total, but the row with index 1. And out of the row with index 1, you select the 0th element. Can we know that it's an 8 straight away? Because if yes, then it would be a simple calculation without taking care of the locations like going right, going down, going left. Now, if you have an algorithm like this, and in fact, we could check out the solutions in some places, like after solving the exercise, if there is, in that case, write it in the comments if you have a better solution. Just, I don't know how YouTube code formatting works, so that's another question if it's a good idea or not. But anyway, you can write it in the comments. If you don't have this idea, and frankly, I don't have this idea in my mind right now, in that case, you can use this plan to still generate the solution and solve it without a problem. So that's what we're going to do in this case. Just for simplicity, let's write a 4 times 4 matrix just in case we didn't know how to solve this. So 1, 2, 3, 4. We go right in the first array. Then in the second array, we place the last element as 5, then 6, then 7. Then we go left, and we got an 8 here. So 8, 7. Then we add the 9 and 10. And then we'll have to move up. So if we move up, the next element is going to be 11. And in the meantime, I'll change the numbers such that we have space for 2-digit numbers too. 11. Next one is 12. Then you know that we've hit the next element, so we cannot move up anymore. We'll have to move right. So then we move right, 13, 14. And now we cannot move right anymore because there is a 5 on the right. So we move down, 15. And 16 is the last possible value because we have to move left. What do we need to conclude? First of all, we have to conclude that the order of rotation is like right, then down, then left, then up. These are the possibilities. And for this, we can very easily check the rotation with a simple if-else. So if you have like a possible rotation, this is like bottom-up style problem solving. In that case, if you know that you went right before, you know that the next element is gonna be down. If you know that you had like left before, the next element is gonna be up. And you know that you will most likely need this type of function. So I'll also write as a note that we need a function to rotate the direction. And in case of direction rotating, you have the horizontal and vertical speed, so or velocity in that way. So Vx and Vy, for example. We'll see how to make these notations, whether it's gonna be x or y. We'll see. I might just use x and y, just like in case of the coordinate systems in mathematics, with the exception that the top left element is the origin, and we increase the coordinates, the vertical coordinates downwards, just in alignment with this array. So for example, if we want to get the bottom elements, in that case, the first coordinate is gonna be 2, and here the first coordinate is gonna be 0. Okay, so we increase downwards. It's very important. So now that we know this information that we need a rotate direction, we know that we'll be able to return something as a tuple with the new Vx, Vy based on the old results. Then we also know that we have to start on the top left of the screen. So we know that, yes, we will have a matrix, which is gonna be created, yes, but we'll need some positions as well. So x equals 0, y equals 0. And we also know that the first direction that we need is gonna be right. In case of right, Vx is gonna be increased by 1, so that's the horizontal trajectory, and the vertical Vy stays 0. What does this mean? That horizontally, in each and every step, you change the coordinates from 0 to 1, from 1 to 2, from 2 to 3, and so on, as long as you can, as long as you move rightwards. Now, if you move downwards, that's another question. In that case, Vx would be 0, Vy would be 1 for downwards. And with this modeling, you will always be able to get the correct element out of the matrix, because you know that in the matrix, as soon as you create the matrix of y and x is gonna be equated to none. So that's what we're gonna do in this place. Y and x, and why not x and y? Very simple. Once again, x is horizontal, y is vertical. So x selects the columns out of a given row, and y selects which row we're talking about. It's vertical. And look at this array. I added this on purpose. Y is vertical, right? Now, if y is vertical, then it means that it selects the corresponding row out of the matrix. You can go to the developer tools, like even in Codility, to get this practice. Oh, weird, but we have quite a few of these issues, doesn't matter. This is the matrix. Now, if we index it, now I could index this data structure, but let me add the let matrix equals this. And if we index matrix, let x equals 2, for example, let y equals 1. What does this mean? So first row and the last element, it would be 4, the end result. Matrix of y is the row that we're talking about. It's the second row. The first row has an index of 0, the second row has an index of 1. So y equals 1. It's this row. And if we want to get the second element out of it, sure enough, be my guest, write x in here, and we get the 4. That's why we need a swap with the x and y values when dealing with a matrix. If you understand this and you learn this for life, then you will have no problems with matrices or arrays of arrays, because you know that first you need to get a proper row and then the column. And to get a proper row, it's a vertical selection. And to get a column out of the row, it's a horizontal selection. And x is horizontal, y is vertical. So you first need the vertical, then you need the horizontal. Enough said about this. So matrix y x equals num. Our program is shaping already a bit of top-down, a bit of bottom-up coding, but it's working. It's all fine. So now we have this matrix y x equals num. But then we'll need to make a move. So we need to know where to go. What's the next step? We need to update x, y, and potentially vx, vy as well. So that's the next step. And in fact, filling the matrix has already happened. But after filling the matrix, also we have to calculate the next index and also end velocity, so that we know which direction we go to. So I would rather write this direction, and so that it's easy and obvious, it's direction. By the way, I'm talking a bit too much to illustrate what is going on, because audience-wise, it's a lot easier for most people to understand the thought process if we do it this way than if I just solved it in like 3, 4, 5 minutes, and then there you go, here is the solution, problem solved. Good luck. And you don't understand half of it. So you see the whole thought process. And then we have the matrix yx equals num value. Now, how do we calculate the next values and direction? This means that we need to get some refreshment of x, y, vx, and vy. And we call this some sort of a function, whatever this function is. It's going to return a tuple. This here is a tuple. It looks like an array, but given that JavaScript doesn't have a tuple notation that has like a group of values, in this case, we use arrays for it. For example, if you use React, just look at the useState hook. It's also a tuple of 2 values. Same thing here, tuple of 4 values. If you want to return 4 values in JavaScript, use a tuple. Unless you want to use an object with proper keys, but here we don't. So we're gonna use then x, y, vx, vy, then move, I just call it move, and put the old values x, y, vx, vy inside. All right, then we might need another parameter in here, the matrix itself. Why do we need the matrix itself? You saw it before. Think about it, stop the video, and once you have the answer, continue with the video, right? So if you want to do this exercise, stop it now, and welcome back. So why do we need the matrix in the move? Because when we try to construct this 12, and remember, we wanted to write the 13 here, and we didn't have all this. Yeah, today's video is sponsored by the German firefighters who do their work at 120 decibels or something with all triple glazed windows closed. Just letting you know. Why? Because some people listen to music. So don't listen to music while solving exercises like this. So we have 12. And in order to know that you don't move upwards to get the 13 in here to reach the boundary of the matrix, but rather move right, because here you have a 1. In order to know this, you will have to know that there is already a 1 in the matrix. And because of this reason, we have to supply the matrix to the move so that it can take the decision of rotating this 12 to 13 and in a way that instead of up, it's going to go right. Because remember, after up, you have to go right, then down, then left, then up, then right, then down. You get the idea. So that's how this is working. All right, now we have the move function. Let's implement the move function. Function move x, y, dx, dy, and matrix. And then we're going to do the following. If we're about to reach a boundary, boundary or previously set value, then rotate. So we have an if, we have some sort of a condition, we'll soon fill this in, and we're going to do the rotation. How? Rotate direction. Same thing, vx, vy equals rotate direction, vx, vy. I'm not going for the most optimized solution for runtime. I'm just going for algorithmic complexity, which is gonna be like you visit each and every cell once, so it's like gonna be n squared, n times n. Linear in terms of the size of the matrix, or quadratic in terms of the size of size of n. Okay, so rotate direction. And after rotating the direction, all you need is x plus equals vx, y plus equals vy. And even if you don't rotate that direction, which means that you don't have to refresh vx, vy, you can still do this x plus equals vx, y plus equals vy. And then at the end, return the same values, basically, after the updates. These are passed by value, which means that you can update them inside, a copy of them, a copy of these that you supply in here. You update them inside this function, and then you return the updated value back, and then you get the updated values. There you go. We could have passed them by reference by wrapping them in a tuple, for example, themselves, and then just return that original tuple. That would work as well. And then you would not have to do this equation, but it's easier to read this way. So I'm always going for readability, because interviewing, it is not a problem-solving exercise in terms of how fast or how accurately you can code. It is a communicational exercise. You have to get your point across to the interviewer, because if you don't, in that case, they might just think, okay, you memorized a couple of solutions, fine, maybe or maybe not. I cannot know, but I have my doubts. I'm not going to tell you that I have my doubts, but I still have my doubts. So maybe I would rather choose another developer who can get their point across a lot better than you do. That's what they might think. And for this reason, communication is more important than sheer problem solving. There you go. So if there is the if statement, what do we need to do inside here? So first of all, we need to see if we reach the boundaries. We could write it in another function, but now I'll just write it as conditions. So we either reach the boundaries. So for example, we index out from the array like horizontally or vertically, or we would reach a value inside the matrix that is already set. We assume that initially, if we have this matrix like this, it's going to be filled by null values. Null, 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 null. Like this. And if that value is not null, in that case, it's already filled. So one option is that out of bounds. So out of bounds condition. The other option is that we do a reserved value or set value in matrix. Let's do the second one first. Matrix of y plus dy, x plus dx. Why this order? Remember, first we do the y to select the row. Second, we need to get the x plus dx, yes. Second, we need to get the cell inside the row. So a cell inside the row is horizontal, that's X. Selecting the row itself, like for example, first row, it's a Y. So first Y, and then if you get the last element, that's an X. And if we make the move, in that case, it's like X plus dx and Y plus dy. And if that value is not null, then it means it's a reserved value, so we have to rotate. When do we have to rotate? When, what other ways? One option is that X plus dx is, let's say, less than 0, or X plus dx is greater than the length of the matrix. Okay. It's an n times n matrix, so let n equals matrix dot length, and it's the same as matrix of 0 dot length. So this is going to be n. And let's see, let next x equals x plus dx. Let next y equals y plus dy. This way we don't have to keep on calculating. It's some negligible change, but we can still do this. So next x, and here as well next x. And same thing with next y. So we'll change this y to next y, matrix of next y. Here we have or next y is less than 0, or next y is not greater than or, but greater than or equal to n. Because remember, we index from 0 to n minus 1, and n is already out of bounds. So if we're out of bounds, or we have a set value, then we have to rotate according to the algorithm that I demonstrated before, right here. So 12 out of bounds, not out of bounds, but value set. So we need to rotate. After up, there is right, because we rotate clockwise. That's it. And after we finish the rotation, we just make the move, whether we rotated or not. We cannot know in here because each step is different. And then we just return the updated value so that we can continue doing our work. Does it matter that after we reach n squared, so in case of 3 times 3 it's like 9, 4 times 4 it's 16. After we reach n squared, we still rotate once. Do we care about it? Well, not really, because whatever these values are going to be, as long as we don't cause an error, these values are all going to be thrown away because we exit from the for loop. And then what do? We just return the matrix. So it's good. The plan itself is good enough. Then what else do we need to do? So this rotation issue. So we have 4 options. I can use if-else, I can use dictionaries, I can do a lot of things. So I'll just use a simple if-else so that people don't tell me that I do ternary operator abuse. So if Vx is 1 and Vy is 0, this means that we are moving rightwards. So we add 1 horizontally, we move rightwards. This means that the next one is down. And it's going to be Vx, so return Vx is 0, so horizontal is 0, vertical is +1 because we go downwards. Very important. But technically we don't need an else here. So we can just say if, because we keep on returning, right? So if Vx is 0, so we're moving down, and Vy is 1, then we'll have to go left. And left is modeled as -1, 0, because we're horizontal. It's the inversion of this. So instead of +1, we go -1 horizontally. Next, if Vx is -1 and Vy is 0, then we go up. Up means that the horizontal value is going to be 0. So whenever you had the value +1, -1 before, that value is going to be 0. And the vertical value is going to be the opposite of what you had 2 before. So instead of 1, it's going to be -1. That's up, because we're getting closer to 0 in this case. And in all other cases, which is basically we were going up because these are the only possible inputs, we just return the value that we selected before so that we close the circle. So return 1, 0. I could use another if statement, but why bother? These are all the possibilities. So we're ready with the rotate direction. The only thing, ironically, that we forgot is the creation of the matrix. Weird, right? So most people start with this, but we're going to finish with this. So first, we're going to create a matrix equals new array of 4. And for each and every value, so for let I equal 0, I is less than matrix dot length, or n for that matter, or actually it's not for, it's n. Good that I reminded myself. So I is less than n, or matrix dot length, and plus plus I. So for each and every value, we'll need to add another array filled with nulls. So matrix of I equals new array of n dot fill null. Because you have this fill method, I could have just added an array of nulls and created it here, but it would be a bit longer. I could have written this in just one line of code as well with another type of solution, where if you wanted to solve it in one, it would be let m as a matrix equals new array of n dot fill null dot map, and then for each and every value, which you don't care what the original value was because they are nulls anyway, you write another new array of n dot fill null. Okay, and that's it basically. You could have written this in just one line of code, but very important. Some people may ask, okay, that's fine, but why didn't we write this new array and fill null inside the fill value? Very important. Verify this, run this in pythontutor.com, for example. Whenever I do live training, I always pay special attention to shallow copies, deep copies, cloning, passing by value, passing by reference. If you don't know how this works, let me know in the comments, and I might create another video on this. A very important concept. This is wrong, this is correct. I'll show you why, just as an illustration, okay? So imagine that you have this matrix, okay? So we have M. Now, okay, we have to have like n equals 4, that's fine. But we have M, and if you check console.table M, it's gonna be a 4 times 4 matrix with null values everywhere. Now, if I add m of 1 of 0, for example, this means that it's going to be this element. We equate it to 12, for instance. Then if you check m, then 12 is in the correct element. Now, if you did the incorrect version with the same type of solution, then, so this was the incorrect version, let n equals this. Okay, and then it appears to be correct. So console.table n, not m this time. And we overrode the n value as well, so it was still the 4 initially, but now it's a matrix. So console.table n, yeah. Let me verify this first. So n equals new array n fill, and yes, you don't need the function here, you just need the new value. So this is wrong for another purpose. So originally I meant this instead of the function. So fill and the new value. So now that we got these anomalies out of the way, imagine that we have this n, but n equals 4 in this time, or in this case. So imagine that you have this, and the matrix is called n. So if you added console.table n, you would have all the nulls. But then let's try to make the same change, but instead of n, we're gonna do n. So n10 equals 12. And then let's try to change this. And let's see if it's a 12 here. So I'm gonna do console.table n, and there you see that the whole column became 12. Why? Simply because as soon as you say fill and you add the value, it's gonna fill it with the exact same array like 4 times. So this means that every single row that you have is gonna be the same. A lot of people make these mistakes in interviews because they just want to be quick instead of thorough. And it's very bad this way, just letting you know. You go to pythontutor.com, you write this down, you see the exact data structures, how these references are repeated in this case. But anyway, I think that you know how to create a matrix now. And let's run the code and let's see if it's working. So running the code, issue x plus equals vx. So I might have made a typo somewhere. Yeah, x plus equals vx. What's the problem in here? Vx is not defined. Oh, because I wrote dx. Yeah, I should have written vx, but you know, it's a mixture of vx and dx. Hopefully it didn't violate many issues. If you noticed it, congratulations for that. So then you paid special attention, and obviously vx, vy has to be here. So run the code. And now you have the proper solution without even debugging, so I'm impressed. Okay, or without having to do console logs or debugging statements. And with that, I think we solved the exercise, so we can safely submit the code. Obviously, there are more advanced solutions, so I'm expecting an appalling result. Actually, it was quite good. I managed to beat 61% with all this overhead of like extra functions, extra variables, extra whatever. But either way, it's fine. So this is the result. This is how you solve an exercise, and hopefully the illustrations made it quite clear that instead of velocity, I used d, because you know it's if you know of university physics, then dx dy, it's like a delta, so it's a change. That's why I use the d instead of velocity. But you can also use velocity per unit time, obviously. That is the same as the change in x and change in y. So that's it. Hopefully you like this problem solving method, and you took a bit more away from this type of illustration than from a 5-minute solution. If you would like me to solve a similar exercise, write it in the comments, or if you're interested in a special topic in terms of software development, then also write it in the comments. Okay, good luck with practicing into your exercising.